So our input data is 10110100. In the DPSK kit, the left side is for 0 bit and this is for 1 bit. And MSB to LSB, I have set it as 10110100. So first I'm going to encode the data. It's given to XOR of the DPSK. This encoded data bits, it is given as the input of the modulator, so that's connected here. And then we have sine 0 and sine 180, which is connected to the corresponding slots here. And then we have the output of the modulator given to the DPSK demodulator. Whatever we get demodulated output, that is given to the input of the differential decoder. So showing the waveforms. First one is the serial input, connecting it to the ground. Continuous trail of 1 1, and then we have 0, and again it follows with 1 0. Yeah, 0 0 1 0 1 1 and 0 again. Next is using the second probe, the encoded output. Yeah, we need to get 0 0 1 0 0 triple 1. So counting from here, triple 1 followed by 0 0 1 double 0 again, and follows by triple 1. Now this encoded input is given to the DPSK modulator. So we'll check the output of the DPSK waveform with respect to the encoded. Yeah. Okay. So every time there's a transition, we see that there's a phase shift. So 1 to 0 transition, phase shift. 0 to 1 transition, there's a phase shift again. Next, I'm going to check the demodulated output. Since this is done with respect to the encoded, the demodulator output as well as the encoder output, it should match. So yeah, both the outputs they match. This is a demodulator as well as differential encoded bits. Next, I'm going to give the differential encoded bits to the differential decoder. I'm using XOR, so make sure that the input data bits and this one is same. You can see that the input data bits and the differential decoded bits match, however there's a certain delay.